try to make this fit in here better. All right, so our first question says determine whether each table represents a linear or exponential function. For each exponential function, write the equation it represents. Now, I want to point out, right, for a linear function, we're working with operations like addition and subtraction, and for exponential functions, we are going to be working with multiplication. Sometimes it looks like division, but we're actually multiplying by a fraction. So, like if you see something that says divided by 2, we're actually multiplying by a half. All right, so let's take a look at our first table. And so we're going to look at the y values and see how the y values are moving. So we go from 4 to 8. So I know I can multiply by 2 to get to 8, and I can add 4. So I'm going to look at from 8 to 12. From 8 to 12, I could add 4, but I can't multiply by 2. So plus 4 is the rule here. And if I'm adding or subtracting, I know it is a linear function. Okay, so let's take a look at the second one. All right, so we have 4 to 8. So again, that could be adding 4. Oh, that's B. Let me go adding 4 or multiplying by 2. Now I go from 8 to 16. Well, if I add 4 to 8, I'd get 12. But I can multiply by 2. So it looks like that's what's happening here. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. And 32 times 2 is 64. So I'm going to say it's exponential because I'm multiplying each value by 2. So to write this equation, right, I take my initial value, which is when y is 4, right? So we know to write the equation for an exponential, to write an exponential equation, let me see if this will let me do it. All right, it is going to be a times b, right, to the x power, okay? And that little caret thing is for the exponent. So our a is our initial value for our initial y value, which in this case is 4. Okay, so our initial y value is 4. And our b value is going to be our growth factor. And our growth factor is how much is being multiplied each time. Well, 4 times 2, 8 times 2. So our growth factor is 2. And we're going to go to the x. Now, some of you might write it as 4 times 2 to the x. That is fine as well. Okay. So I like both ways are fine. So let's go to C. C is, let's take a look. So we go from 81 to 27. So from 81 to 27, then we go from 27 to 9, then we go from 9 to 3, and from 3 to 1. So I'm just going to work backwards to see, okay, so this way I had to divide by 3. I'm just taking the smaller numbers because it's easier for me, or subtract by 2. 9, I'm going to do divide by 3, and I would have to subtract by 6. So it's definitely not addition or subtraction here, right? And I know I'm going backwards, but I'm going backwards because it's easier for me to work with smaller numbers. So dividing by 3 from here to here, so it's actually multiplying by 1/3. So if I was to multiply 81 times 1/3, so we have 81 times, and I'm gonna make it a fraction, 1/3, which is actually 81 divided by 3, and that's 27. So our next one would be 27 times 1/3, and that's 9. So it's fairly easy to come up with an equation from here. This is exponential, right, because it's being multiplied by 1/3, right, each time. And our a is our initial value, right? So our a is 81. And we're going to multiply that times our b, and our b is our growth rate, which is 1/3. You don't need to put the parentheses when you have that there. I like to be specific with parentheses, but I'm just going to write it. I'm going to put it in parentheses. I like doing that, especially when I'm talking about fractions, so that you see the exponent correctly to the x. And we know it is an exponential function. Okay, now another way you could have done that, if you're like, okay, I know it's not linear, you could also go into your calculator, hit stat, edit, okay, and you're going to put in your x values for line 1 and your y values for line 2. So the values are right here. So for x, I have 0, 1, 2, 3, 4, and I think it goes to 5. No, just to 4. Okay, and for y, I have 81. Okay, 27, and 9, 3, and 1. Okay, so I have my numbers in. Now I'm going to hit stat again. Let's see if you can see I'm going to go stat, calculate. And then I'm going to go down to where it says expo regression, right? Exponential regression. Hit enter, and then I'm going to let it calculate. And we have our A is 81 and B is 0.333, which is actually what 1/3 is as a decimal, right? It's a repeating decimal. If you were to put 1 divided by 3, this is what you would get. Okay, so if you're not sure how to do it using the formula, you could always rely on the calculator. So let's take a look at the next one. 125 goes to 15, goes to 105. Okay, so I see a pattern right away. And again, if you don't, you can do some other calculations. So 125 to 115, I have minus 10. Okay, 115 to 105, minus 10. 105 to 95, minus 10. So that is happening. So it's linear because I'm continuously subtracting 10. Okay, so let's take a look at number 2. Let's see if I can make this bigger. All right, number 2, use the given function to answer the questions. Okay, so we have f of x. Our initial value is 127. For g of x, our initial value is 7, right? A is the initial value. And for h of x, our initial value is 700. Remember, the formula is a, b, right, to the x, and our a is our initial value, our b is our growth factor, and our x is our amount of times, right, that it's happening. I'm also going to put up the answer key online so you'll be able to see it. I just wanted to go through it so you can see what I'm talking about. All right, so the growth factor in this case for f of x, right, is b. It's just 7 over 4. Let me move this. Put it here. It doesn't like this at all, but let's see. Okay. G is 5 over 4. Okay. And h, the growth factor of h of x is 11 over 4. Now, the next question asks, which function has the highest growth factor? So, 7 over 4, 5 over 4, 11 over 4. So, 11 over 4 has the highest growth factor. Because if you were to see, right, they're all greater than 1. And 11 over 4 is the greatest value. And I could do the division, but I feel like you could do that on your own. Like if you were to put it in the calculator and go, right, 11 divided by 4. Okay, 11 divided by, oh wait, it wasn't 11, it was 5 divided by 4. Or 7 divided by 4. you could clearly see that the 11 fourths is more.